A while back in a video, I repaired one of the coils on this motorboard, and that generated some emails and questions about, did I have a source for replacement coils? Did I plan on maybe making them? Anything like that. I don't have a source. I wish I did. I've actually tried a couple of times to see if I can get somebody to make them reasonably, and I didn't have any success with that. So this is my attempt at trying to wind my own axial coils, along with my triumphs and failures at it. I thought what I would do is 3D print a form and then wind the coil, bond it, and then break the mold and or break the form and have a coil. And I thought it might, I knew it wouldn't be easy, but I thought I was certainly capable of doing it. So this is my second attempt on this one, I believe, using the conventional coil enamel or insulating enamel. And I've let this sit overnight, which was, I think, 10 hours in their data sheet recommended. And it's not even close to cured. It's not wasted because I still have a coil that I can measure, and I do need to determine the number of windings, and the only way I know to do that is to make the coil and measure it. So obviously it's too small for my insulation remover. I'll just have to scrape it off. Now the first one, I'll show you here in a second. I actually just used super glue to bond it together so that I could quickly demold it and measure it. These are really, really thin and hard to handle. Okay, I think that's good enough. Maybe. Get this where the camera can see it. What I'm shooting for, based on the other ones that I've measured, is maybe 13 and a half of those little horseshoes there. Maybe just a little bit under that is fine. I've got a couple that are have been up in the 16 range, and those decks have not performed as well. So in the absence of data, I am completely going off guesswork. But I've measured a few of them, and they're 13 and a half to 14. You can see this one is still not cured up, and that's a whole other set of issues that I'm learning about. This material, it seems that it won't cure up when it's tight in this little form here, this mold, because no air can get to it. And so I may have to find some kind of an anaerobic insulation cement that's compatible and won't break down the enamel on here. Super glue may be fine. I don't know. but I have to find these things out. And I have done both. The overnight setting, I've let them sit in warm places. I've cooked them. In their data sheet, they say 2 hours at 175 degrees, something like that. And I do have a lab oven, and I tried that, and it was better. It helped. I suspect it would take maybe a week or two. But I think that's the problem, is there's no air that can get in there and actually cure it into the center. So there's a couple of the attempts, and this isn't wasted. I'm able to measure these and get an idea of the windings, and I'm starting to get dialed in now into the number of winds that I need. So these are the latest ones. I've got, I've added some holes in these to try to get the curing to happen more effectively. It helps. I can kind of get them dried, not cured, but I can get them dry. Okay, so that's pretty much bang on 14. Okay, a few more needed here. So basically I'm getting the numbers dialed in. I'm not having success at demolding the coil without it coming apart, typically from the center. So somewhere between, 247 and 212 winds will get me where I need to be, and that's fairly consistent. Okay, so I've got these laid out, and I've got the insulation stripped off, and now I want to see if I can get it broken apart and get a working coil. Let's speed through this. Now you can see the little holes that I've included now in these molds, forms, whatever I want to call them. And on this one here, I went both sides. So this increases the print time a little bit. I'm not too worried about that. If I can make these work, I can print a whole tray and, get it done. But without being able to get that coil successfully out, this is all just superfluous. Oh, and the other thing, these have all been heated in the oven for several hours and then sat overnight. And the other thing that's happened is the form has shrunk a little bit. You'll see the one side pops off no problem, but the side that has the inside profile is where I run into all the problems. And I've tried probably 3 or 4 different release agents, very high-tech aerospace grade stuff that I have here. I've even reverted to pure paraffin wax, which actually worked really well, except for that right there. The center part gets hung up, and even up to, I think I went to something like 7 degrees of draft on one, and it made absolutely no difference. In fact, it's almost like the more draft, the harder they were to come out. So it isn't that. There's something else going on here. But I keep trying. Every so often I do have success with one. This one I heated up with a heat gun after it had cured. I'm just trying to, do something to get this inner mold off. And the heat helped a little bit. But again, it's not a consistent thing. I can get one or two, but I can't get them consistently off. So this one heated up, pops right off of the flange part, no problem. And it seemed to also come off of the inner profile, but it's also extremely soft. And so that's probably why, because it's hot and it's softened up and it's no longer cured. But like I say, it's okay. These are all things I need to measure, but see, this is not an acceptable coil here. That shouldn't pull out of there so easily. And again, this is fully cured or fully dried according to instructions and so forth. So this is not acceptable, but I'm still working on it. Got one more on this round. This is obviously a compilation video. I've been working on this for some time, and it takes drying time and so forth to make all this happen. So I'm going to try to heat this one up as well, and I overdo it a little bit. It's kind of just, now I've just melted everything together, so this isn't going to work. So at this point, I've got a lot of different ideas on how to make this happen, and I'm just kind of working my way through them. And I'm certainly not a mold maker, and God bless those that are for their patience, but I'm not completely unfamiliar with it either. And I do know that if this were a mold that was made out of steel, or a form that was made out of steel, that I would not have these problems debonding. I know it has to do with this 3D print, but I don't know why yet. Now, I'm betting some of you out there are watching this and thinking, well, why doesn't he know? It's so obvious. But I get there. It just takes me a little while. Sometimes we get fixated on one particular thing and we don't see, actually it happens a lot, we don't see what's around us that can make things so much simpler. But this isn't wasted. I'm learning the limitations of 3D printing, and they are many. But this is typical of what's happening to, maybe not to this degree, but those coils in the center profile are getting hung up. And right at this moment, I'm focusing on the wrong reason they're getting hung up. So now I put some parting marks in the 1/2, and thinking that if I can just get it wiggling a little bit and not be so firm, that I might be able to break them out that way. And that's actually, you know, it's debonding a little bit there. That looks promising. Now that's the troublesome side. That's the side with the inner profile. The other side will pop right off. That's not a problem. But see, this is way too much time and way too much effort for any sort of a production model. So I already know this won't work, but I'm following it through because I've committed to it. Just kind of walk it around there. Looks promising. See, it appears to be hung up on the flange, but now I know it's not. And once again, it's separating the coils. So, and it's not dry. I can tell that the inside of that is still not dry or not cured. So we'll put it back together, put it back in the oven. A few hours later, we'll try it again. So I'm obviously trying to push the coils back. You can kind of get a glimpse of it right there. And, you know, yeah, it comes apart, but the coils are loose. So that didn't work, but it was a good thought, good try. That's one of the better breakouts on that side, or maybe the best breakout. But you can see that it's just so much prying and everything to get it apart that it's damaging. More cosmetic damage. If you look at these things close, they're far from perfect. The factory ones are too. There's a lot of variation in them. that part doesn't bother me. If I could straighten them out and get them bonded, then that would be fine. I'll have maybe a little bit more adhesion in there. A little bit better bond, but not great. So this is the first one, and this is the one I used super glue on, cyano, and it held together. It came out okay, but there was damage done to it, and it also, I had to take some of the plastic off, the mold off with it, but it did get a little bit damaged. So here are my failures and successes, or some of them. Some of them are in the garbage. I even did a split mold on one, thinking that would be a possibility, and that's actually fairly promising, but it was so fussy to try to put it together and make it a single piece that I gave up on that one for the short term. I may go back to it later. Now, in this one, I redesigned all the small holes on the cap and put, I think, 5 larger holes in there. I thought maybe I could use those as something like an ejection pin hole that I could possibly push on the back side of the coil and release it that way. And of course, that didn't work either, because it still got hung up in the center. It did work, but it still got hung up in the center. But the secondary part of that was having larger surface area for air to get in and dry that insulation enamel. Now, I've also put parting lines on the other side, on the other part of the mold. Let me get that apart. It should pull apart. Oh, great. I needed that nail for another job. So again, even if this was successful, this is not a production model. This would never work. No problem on that side. That'll pop right off. So this is kind of the ejection pin model. And yeah, I do have something a little more sophisticated for that, but I'm just testing it now to see if it works. And it kind of seemed to break it loose there. Just wiggle that around a little bit more, kind of disturb the try to just break the bond, and there's okay. So that felt good. That leg got stuck in there, but that's fine. I can live with that. Well, that iteration might have some possibilities to it. Now this was again a super glued version. It might be possible that there are some anaerobic adhesives that would do this just fine, and I'm not aware of them. I have to do some research and see. But that seems to work better than the official enamel. So I'm just going to clean all that up and now coat it with the enamel. And yes, I removed the child-proof safety cap because I am an adult with arthritis, and I don't appreciate that. So the super glue will help me bond or debond it and hold it together. I think it's okay. I don't think it will break through the wire coating, but like I said, I don't have data on that, and I need to find out. And I'm sure that there's a fast cure or an anaerobic or something that can be purchased to do this job if this is the thing that ends up working. If anybody knows, let me know. Put it in the comments, email me, call me, something. And we'll let that cure up and give it a test. I think I'm pretty close to the correct number of windings on this one. We'll get the measure out and get another digit on there. Just hold it on there. Okay, I'm feeling pretty good about this one. Getting nice and warm, and it's pretty stable. It's not going through the roof. I'm looking for, somewhere around 125 degrees, again with absolutely no knowledge if that's the correct number or not, but I don't think it would get much hotter than that in use. I don't think it would ever get that hot, but or even close to it, so I feel like that's probably a pretty safe place to be. And some of you are probably shaking your head at this point and saying, why can't he see why he's having so many problems releasing that coil? And I could eventually see it, and obviously the reason why is because the diameter of the magnet wire is considerably smaller than the layer lines of the 3D print. And here is the actual magnet wire just resting on top of the actual 3D print of that profile, and you can see that it's quite a bit smaller. And when it's wound around there tightly, it falls right in there, and it makes an interlocking jigsaw puzzle. And so what I was trying to do, it didn't matter how much draft I had on it. It's as though I was trying to pull the bottom log out of a stack of logs without disturbing anything above the bottom log. And it's not going to happen. And so a traditional mold or a traditional form in steel that was smooth with normal amount of draft would work just fine. And I know it would work just fine, but like I say, I was fixated on one thing and I never considered these layer lines. And yes, I can see that I'm probably, my Z's a little bit too low, but regardless, if I lower it up, I'm going to have greater distance between those and more interlocking. So from this point, we'll be making metal mold or metal form with, of course, smooth sides on that inside profile, which is what I need. And whether I do that here with the traditional way of doing it or send the file out for bid on CNC work, I'll decide that later. But that's why it didn't release, and that's why now I know how to make it release. I went as far on this as to make these two fixtures fit the holes in the little molds so that I could both use it as an ejector if I needed to, because these pins are removable, so I can make them any length I need. And of course, like I said, that didn't work. It did work, but it still couldn't bring out the inner profile. But then the other intention was to have them put tension on the two halves of the parts and then twist them rapidly, hopefully breaking that inner, right there, that inner part, inner diameter profile, breaking it and leaving it inside of the mold. And it worked, sort of. Didn't work as well as I thought. It is promising. I could probably do it. But let me make sure this is focused here, and I'll show you what the idea was. Sorry, I thought that was focused. Anyway, that was the plan, was to just rapidly twist it, obviously in a vise with a pneumatic tool or something like that, and have it just break everything off at one time and leave that piece right there in if that was necessary. It wouldn't hurt a thing. I could do some more experimenting with that, but now that I looked at it under the microscope, I know that what I really need is a smooth surface. And then it can work in the traditional way. My setup for doing this, very simple. In the lathe, using just my hands to tension the wire a little bit. I'm not really putting much tension on it at all. It's also pretty much guiding itself. The only time I really intentionally guide it is on the last little bit, so that I can make sure I've got a relatively perpendicular side, but it pretty much does it on its own. I'm doing this pretty slow to begin with. As I get into it a little bit more, I speed things up, and it really works just fine. I could easily build a tensioning device, but I've got a pretty good feel of it this way. And then for the counter, it's just a very simple digital counter with a Hall effect sensor on the outboard spindle. You know, just a temporary setup, nothing fancy, but it works. And that's how I did it. So there's pretty much the whole production, except for what's in the garbage can. And stay tuned for the next episode. Thanks again for watching.